Good morning. Today I want to try and get this video up there. You cannot believe how many times I've done this, so hopefully this is the last time. Scatter plots, just a quick review for you. To create a scatter plot, just remember you have a table here, X and Y values in it. And what we're going to do is we're going to plot those values on the graph. So 2, 4, 5, 2, 7, 7, 8, 6, 11, 9, 12, 11, 13, 14. Okay, so there is how you create a scatter plot. Okay, so just a quick note, positive correlation. If you were to try and just draw a line of best fit through here, look like that. Anyway, you'll see those in upcoming questions that you will have. For example, here it says draw the line of best fit. And so that's what I'm going to do here. But I'm going to keep in mind that I want to have whole number values just to make it easier to write my equation. And let's see, so I am at 10, and what if I went to 10? Whoops, that would be 11. So 10 would be like there. Okay, so there's my line of fit. You're, of course, going to use the tool. Start out in yellow. Okay, so if you were going to write the equation of this, y equals, we did an intercept at 10. I intentionally went down 10 and over 10, which would be to simplify into -1 for a slope, which would give us y equals -x plus 10. So on this question, you didn't have to write that, but on upcoming questions, you will have to write that, okay? So here we're given the scatter plot and the line. We're asked a few questions about it. As the time spent texting increases, the time spent exercising tends to, and this is exercising, and this is texting on X, exercising on Y. So as X increases, Y decreases. Okay, that would be a negative correlation. Okay. There is a negative correlation. Using the line of fit, we would predict the number, predict that a student texting for 5 hours would exercise approximately, well, let's see, texting 5 hours. We go up to the line. Let's look at the Y value there. Okay, that Y value is 5. Okay, so predictions, more predictions from the line of best fit. So here it says use the equation of the line of best fit. Very important to note, use the equation, okay? Because you could use the line, or you could actually take the actual values at the points. There's a whole bunch of different things that we could do here. So if we use the line, then we're going to see that we're going to put into this equation, if we use the equation, pardon me, here it says who spend 12 hours watching TV. Well, the hours watching TV is on the x-axis. So we're going to put a 12 in for x. So negative 77 times 12 plus 26.08. Okay, negative 77 times 12 plus 26.08. It gives me, I did something wrong. I'm working without looking at the screen, but looking at the buttons that I'm pushing instead. So you can put it in your calculator, and I try to teach you to always be on putting the numbers that I'm talking about into your calculator. Because, why because? Well, because I'm busy doing other things. So here, I'll do it again. Negative 0.77 times 12 equals plus 26.08 equals S arrow D, 16.84. Okay. What is the predicted time spent doing homework for a student who doesn't spend any time? Okay, so look, negative 77 times 0, that term is going to go away, plus 26.08, right? 0 times anything, so 26.08. For an increase in an hour in time spent watching TV, what is the predicted decrease in the time spent doing homework? So it's talking about the slope. We're going over 1 hour watching TV. What happens here? Well, the slope here is negative 77 over 1. So it decreases 0.77. Now, it shouldn't want you to put the negative in with that because it's already done that when it said decrease. See, it said, how much does it decrease? Well, decreases by 0.77. Okay, so here we're going to write an equation of best fit, use it to make predictions. Okay, scatter plot shows it doesn't have to be perfect. Okay, so again, you're going to use your tool to make the line. And when you do, again, I strongly suggest that you pick some value that you can use as a whole number here. I picked that point, which is at 26. And then I'm going to pick another good value. In other words, where is it crossing on the graph? Okay. Now my line's just a little bit low, but it says approximate, so I'm not going to worry about it. Here, from 26 to 4, I went down 22, and I went over 28. That's the same as down 11 over 14. Negative 11 over 14 times x. There is my equation. Okay, now I'm going to put a 12 into my equation. So do this in your calculator. Negative 11 over 14 times 12 plus 26. And then, you know, you may have a different equation than me. So if you do, that's cool. That's fine. What you're going to do is put what you get in there. Okay, so let's talk about correlation. We have what's called the correlation coefficient, R, which is always going to be between -1 and 1. So going out from 0, if it's a positive correlation, going out from 0, the closer that the points get to being in a straight line, the closer to 1 we get. The further away we get from being in a straight line, the closer to 0 that we get, okay? Closer to 0. The closer we get on a negative correlation to a straight line, the closer to -1 that we get. So let's look here. Which data set appears to show a positive linear relationship between its two variables? Well, I would say the yellow one, positive linear relationship. Which data set appears to show a negative linear relationship? Well, that one, the one that I made pink. Which data set appears to show a non-linear relationship? Non-linear. Do you see the parabola there? I would call that non-linear. And which data set appears to show relationship? No relationship. Well, no relationship. I would say the one that I made green shows no relationship. Okay, so moving right along, correlation coefficient. Which data set indicates the strongest positive linear relationship? Strong positive. Strong positive. Well, look right here. Strong positive. Okay, for which data set is the correlation coefficient R closest to 0? Closest to 0. Look right here. Closest to 0. In other words, the points are scattered the furthest apart. For which data set is correlation coefficient R closest to -1? Closest to -1. Well, right here. Closest to -1. Okay? So hopefully that helped you. So now we're going to talk about the residuals. Okay? Residuals are the distance that we measure between the line of best fit and the points. So notice there's a little distance there between each point and the line. See the distance? See, if we measure all those distances, those are the residual values, the distance between that point and that line, that point and that line. Okay, those are called residual values. So the way that we would find them algebraically, okay, I made the mistake of making this screen large and now it doesn't want to go small again. There we go. Okay, so we're going to take the observed value, in other words, the value at the point, and we're going to subtract from it the predicted value. In other words, the value that the equation gives us. So the observed subtract the predicted. Okay, so let's look at what that looks like. So here's our point values, the Y column. Here is the value we get when we put the X value into the equation. Okay, so we're given this equation down here. So the Y value that comes out when we put in this X value is that. Okay, so the residual value, we take the observed value and we subtract the predicted value, and that equals our residual value. So the observed value minus the predicted value equals our residual value. The observed value minus our predicted value equals our residual value. The observed value minus our predicted value equals our residual value. The observed value minus our predicted value equals our residual value. And if you add up all of the residuals in a scatter plot, if you were to add these all up, the sum should equal 0, because your line of best fit should be exactly centered between all those points. So, and we call it a regression line when it is. So let's compute a few residuals. So here they've asked us for 4.9, and they've asked us for 9.0. So let's do that. So get your calculators handy. Okay, so the observed values coming out of the table. So at 4.9, we get 14.50. And at 9, we get 13.90. Now we have to use our equation, which is 0.8x plus 8.48. So in the first line, we're doing it for 4.9. So we put 4.9 in instead of x. So -8 times 4.9 equals plus 8.48 equals SROD -30.72. Did I do something wrong? I'm going to try this again. Okay, now I'm using both hands. -8 times 4.9 equals plus 8.48 equals SROD -30.72. Oh, okay. I forgot my decimal point. Okay, so it is 3.072. So let me try that once more. -0.8 times 4.9 equals plus 8.48 equals SROD. 4.56. How could I be so wrong? And then what we're going to do is we're going to subtract 14.5 minus 4.56, 9.94. And my arithmetic might not be perfect. That's why I ask you to use the calculator. I'm doing like 10 things, and this is honestly at least the 20th time I'm trying to make this video. So now I'm going to do for this equation, -0.8 times 9.0 plus 8.48, -0.8 times 9 equals plus 8.48 equals SROD. I get 1.28 here. And I'm almost sure that this value is incorrect. I'm just not going to take the time to do it again. You're welcome to check. But there's lots of opportunities to make mistakes here. Residual plots. This should be the last of the things we need to learn. So we're going to graph the x value and the residual value to see how good our regression line models the data. Okay, so if it's linear, I'm going to show you some residual plots that show the linear model is not good. Okay, first, 3 things that we're going to look for to see that it is appropriate. equal number of points above the x-axis and below. No obvious patterns. For example, we should not see a linear pattern in our residual plot. We should not see an exponential or quadratic pattern in our residual plot. Small values for the residuals, y-axis. Okay, those three things will show us that our linear model is a good model. Okay, so here are some poor models. Okay, see, these points are pretty far from the x-axis, which means they're pretty far from the line of best fit. Also these ones. Okay, so then we come over here and we see a quadratic pattern. We see an absolute value pattern. These are indicating that a linear model isn't going to work for us. All right, so now let's look at your question on Alex. Okay, so you're going to match scatter plot A, B, and C to residual plot 1, 2, or 3. So let's just start with the one that is following a straight path. Okay, there is no distance between each point and the line. So when we plot those values, right, that means there's going to be no distance between the x-axis and those points. Again, what we're doing here is we're making a table that would eliminate, I'm going to just do it, would eliminate these columns here. So we're just going to plot x comma residual value, x comma residual value, x comma residual value, x comma residual. So this is our new table right here. That's what gives us our residual plot. Okay, so going back to this question here, now when we look at this one, we can see x comma the distance between that line, x comma the distance between that line is going to be like this one. It's almost like we take the line of best fit and we transition it down or project it down onto the x-axis. Okay, and finally this one, notice it's a quadratic shape scatter plot and it's a quadratic shape residual plot. It's like we took this line of fit, whoops, and moved it down to the x-axis. We got to go back to the narrow point. Okay, so anyway, questions, ask them online. Thank you very much.